All right, so I'm going to cover climate projections for the South Central United States, as well as a little bit of kind of background and modeling, and again, trying to engage you throughout. I'd love to see polls reaching 100% response, so let's see if we can do that. A little bit about me before I get started. I'm originally from Arkansas, but I've been in Oklahoma since 2009. I came here to get my degree in meteorology from OU, and then stayed here to get a secondary degree in geography because I wanted to do what is climate impacts and how does it impact people and how did people impact the climate. I have been at the South Central Climate Adaptation Science Center in a full-time position since about 2017. And my hobbies, as I mentioned earlier, I love to bake, but I also enjoy wildlife photography. And I have kind of interspersed a few of my favorite creatures throughout this presentation. So I hope that those bring you a bit of joy. Why use future climate information? Well, future climate information helps us understand what things might look like in the future. If we're not using that, it's a lot like driving down the road looking in your rearview mirror, which is all well and good so long as that road is straight. But what happens when that curve comes around? If you're only looking at past information, you're probably going to miss the curve and miss it. You might end up off the side of the road at worst. So being able to look ahead, see what that future information looks like, can help us prepare and plan for what's to come. So what does the future look like and how do we know? And again, these are two of my fun furry creatures from the Rocky Mountain area. Global climate models are how we kind of understand what the future might look like. For decision makers to do their jobs the best that they possibly can, they need to know what to plan for and what risk there might be in the future. So climate scientists use these models where we take the laws of physics and we build these basically computer models of the Earth and the Earth system. They're called global climate models, and they're not intended to predict a specific event on a specific day. That would be insane. But they are to help us see general trends, how things might change compared to recent and even further in the past. Climate scientists will validate these models or kind of check how well they're doing by running them in the past. And then they compare those results with observations that have been taken over time. So the simulation that we're seeing here is one of those global climate models projected backwards in time. The physics of the Earth doesn't change. So we're pretty confident when we see the models run like this, that we can have faith, I guess, is one word to describe it, in what they might show us in the future. So when the models, again, are satisfactory in this past climate, we see them kind of projecting these various tropical cyclones. We see them catching that intertropical convergence zone that Renee was talking about earlier, and they're getting the general patterns correct. We know that the model is built well and we can use it to plan for the future. Okay, so first poll will hopefully launch pretty soon. Okay, looks like it's launching. So global climate models calculate variables using what? Okay. Leave it open for just a couple more seconds. All right, we'll go ahead and end that poll and share the results. All right, it looks like, okay, most people did, yes, it is the basic laws of physics that are kind of driving these global climate models. Statistics of weather and equations describing the statistical relationships between observations and model data. We'll actually come back to that. It's not used in the global climate models. That's how kind of we're taking these global climate models to regional models and making them more high resolution. Great job. As we're thinking about the future, we want to know what might happen, and something that creates kind of a range of possibilities is human decisions. So what society, what economies, what countries might do in the future as it relates to greenhouse gases. Scientists have developed this range of what we call scenarios to help capture what those might look like. The higher end scenario, also referred to as RCP 8.5, is what's considered the business as usual. So we keep using greenhouse gases, fossil fuels, or we keep using fossil fuels as we currently are, and maybe even increase that amount as developing countries come on board or grow their economies using these fossil fuel-based technologies. The RCP 2.6, or that kind of lowest end scenario, is what's known as the peak and decline. So we see that greenhouse gas emissions dramatically decrease in just over the next few decades. So there are significant policies or technological advances made, and we shift maybe to more renewable energy or sustainable energy sources. What's important to note here is that that higher scenario that we see by the end of the century, it is much higher. It has a much higher impact on our projected change in temperature, for example, than that lower scenario does. We can look at those maps for those scenarios or we can look at those graphics as the scenarios in this map form, where we can see how things might change across different geographic locations. So these are those global climate models showing us what temperature might look like across the United States and North America over the next, I believe this is for 2100, so towards the end of the century. Again, we see that lower end scenario not warming near as much as the higher end scenario, but in either case, we do expect some type of amount of warming, which is important to plan for. We can also look at projected changes in precipitation. And as Renee mentioned in her presentation, not all locations are experiencing the same patterns. So we do see areas projected to get wetter in the future, as well as areas that are projected to get drier. It also kind of depends upon what season you might be in. So this one is broken out by seasons, and we see certain seasons, like the summer, where more areas are expected to get drier. But these graphics, as I mentioned, are pretty low resolution. They're really hard to make, decisions on a local scale using this type of information. So that's where downscaling comes into play, which is where we build relationships, those statistical relationships between the model data and observations that have been taken through like the Oklahoma Mesonet, which are about 120 stations across Oklahoma gathering weather data all the time. COPERAS is another one that that type of data could be used to help take these really big boxes and make them much smaller, so that now in that left-hand image where we weren't really sure, we could kind of see where the Rocky Mountains were. Now in that right-hand image, we have a much better, much finer picture of where those mountains are and how just in short distances, you can experience drastic differences in the projections. All right, so I'm gonna launch another poll and talk a little bit about what is a climate change scenario. We just talked a little bit about that. Maybe just another second or two, and then we'll go ahead and close. Okay, we'll go ahead and end the poll and then share the results. Yes, climate change scenario is a possible sequence of events that may lead to changes in our future climate. They are not specifically a type of global warming model, but they are used in the models to help us get a range of possible futures. Regional climate projections for our region. So all the ones that I'm going to be showing to over the next several slides are for mid-century, which we've defined as 2036 to 2065. And again, a couple more kind of fun, furry, and feathery creatures for you. Before I show you the projections for our region, I want to go over a little bit of fine print. So projections are not forecasts or predictions. Again, they're not designed to tell you exactly what things might look like on a specific day, on a specific year, but again, rather it helps us see general trends. Our ensemble of projections are developed using 3 downscaling techniques, 3 historical observation data sets, and 3 global climate models. Each individual model output looks a little bit differently, but we can essentially average those together to create these ensembles to see what the general trends might look like in the future. So as we look at the projections over the next several slides, keep in mind these are just showing us general trends, but as we'll see in the climate projections training tomorrow, it's important to look at the individual models to not only see what the general trend is, but what that range of possibilities could be. So again, if you're wanting to do that training, I would encourage you to do so, and please let me know if you'd like to do that. All right, the first projection for our region, and I hate to be the bearer of bad news, but the next several slides are not the most fun thing to talk about all the time. But it is going to get warmer, is what we project, is what the models suggest. So daily high temperatures, average for much of our region, are expected to increase anywhere from about 2 degrees Fahrenheit all the way up to 6 or 7, depending upon kind of where you're at. And again, pretty much just warming across the board. Oh, I should, let me talk a little bit about, so on the left-hand side of these 2 pair images is going to be that low scenario that we talked about, that peak and decline. And on the right-hand side, it's going to be that high scenario, or the business as usual. And that'll be pretty much the same in all of our graphics, except for when I show you seasonal. And this is an example of one of the seasonal graphics where we're still looking at that change in the daily average high temperature, but we see that when we look at the different seasons, it's really summer where those largest changes are expected to occur across much of our region. Let's see. We can also look at the projected change in daily low temperatures. And we see that those low temperatures are also expected to increase as well by about, again, 2 degrees to 6 degrees. This is unfortunately not great news when we think about even something like human health, where at nighttime, it's often the time where our bodies need to rest and relax from the hot temperatures of the day. And if we aren't getting that cooling period that our body needs, it can really start having some negative health impacts. So that's something that as we talk about these projections, it's important to think about how changes in temperature not only affect people, but how it's affecting the ecosystems you're managing or the water resources that you're managing. And I would love to hear from you in the chat what changes in temperature really might mean for the things you're managing for. What does that look like? So feel free to write that in the chat or unmute yourself real quick and say what that is. And Christian, if you could read those aloud, that'd be great.
Philip says more flooding. Richard is saying higher cooling bills.
Mm-hmm.
We've also got my peach tree won't bloom. That is very sad. And less aquifer recharge.
Mm-hmm.
And changes in water quantity and quality.
Indeed, yeah, yeah.
And
Certainly.
also water shortages.
Yes, yeah. So we'll talk about precipitation in just a moment. But yes, you know, temperature can certainly have impacts on that as well through increased evaporation and increased evapotranspiration. All right, we'll go on to the next slide. So we can also look at thresholds. This is looking at the average number of days per year that the high temperatures get above 95 degrees Fahrenheit. I don't know about you, but I generally don't like it when it gets above like 75. So when I see these types of graphics, I'm not super thrilled. And I think about where I might want to move that it doesn't get so hot. But for our region, even on that kind of low end scenario, it's an additional 20 more days above what we're used to having of those high temperature days. And in that high end scenario, now we're looking at 40 to 60, depending upon where you might be across the region. Similarly, we can look at what happens if that threshold is set at 100 degrees Fahrenheit. This I really don't like because for those of you who were in this region during the summer of 2011, it was very hot. We had significant drought issues. And so that type of summer, that type of event or series of events is likely to be kind of more normal, I guess, in the future, where we see the number of very hot days projected to increase by 10 to 65 or 70, really, across a good chunk of our region, especially along kind of that El Paso area further along the Red River, or not Red River, Rio Grande. This is looking at growing season length only based on temperature. So we recognize that there are numerous other factors that, that drive exactly growing season length. But if we just look at temperature, we do see growing season length, particularly across the northern half of our region, projected to increase, which this may not be a bad thing. But again, this is only one factor as it pertains to growing season. All right, now we'll shift gears and look at precipitation. And so this is the average annual total rain or snow expected to fall in our region. If you look at that high scenario, much of the region, especially in kind of the Texas Panhandle, Oklahoma Panhandle, up into Kansas and down into southeast New Mexico, experiencing or projected to experience some of the driest conditions in just a few decades, really. Again, this is mid-century, which we're almost in mid-century. And again, looking seasonally, we see that it varies, right? It's all dependent upon kind of what season you might be in, where you might be located. Spring for Western New Mexico looks particularly not great, but in general, we see summer and fall being the periods of time where kind of those greatest decreases in rainfall and snow might occur. And then average annual longest dry spell length. So dry spell here is defined as any period of time where precipitation is absolutely zero. So when we look at the projections, we see that those periods of time are projected to increase by about 1 to 2 days across a good chunk of our region, especially throughout New Mexico, western and south central Texas, and then western Oklahoma. Again, for that high-end scenario. But just because we see a lot of drying in the future, it doesn't mean that those floods won't happen. Actually, because with a warming atmosphere, that air can hold more moisture. So that when it does rain, it can actually rain harder. And those extreme precipitation events, like the exceptional daily rain or snowfall events, we project, or our models are projecting that those events could get more intense as well. So those, even though, yes, droughts, and we talk about drying conditions a lot with climate change, it doesn't mean that those extreme flooding events won't happen anymore. It certainly means they still can, and they could actually be worse as well. All right, one last poll for me. Different climate models will. What will they do? So we talked a little bit about this at the very beginning. All right, we'll go ahead and close the poll and share the results. Indeed, yeah, they can actually produce different climate projections. So different climate models, some of them, yes, will look similar, but not all of them will. There are some, and again, you'll see this if you join us in the training tomorrow, which I hope that you will. You'll see where there are certain areas in certain projections that are expected to get really dry, and then in another model, it could get really wet. And so being able to know how to deal with that type of information and plan for that range of possibilities is what we're going to try to start the dialogue on tomorrow during our climate projection training. All right, thank you. Some just kind of last minute additional information. If you're interested in these maps or others, please email our info@southcentralclimate.org or schedule a virtual visit with us. We would love to talk about kind of what your specific needs are. We do have end of the century graphics too for 2070 to 2099 if that's something that you're needing to plan for. And again, as Renee said, the National Climate Assessment is a super great resource, and we encourage you all to read through various sections of that. And again, yes, we would love to connect with you. So follow us on Facebook and Twitter. Sign up for our monthly newsletter, which you can access on our website. We're hoping to take this Climate 101 and make kind of a secondary Climate 201 at some point. And we'd love to get kind of your feedback on what you would expect from a 201 version of this type of course. And then I also have a few links up there, just additional resources and our partners who also work in the climate related field. So Skip, who is also here at the University of Oklahoma, and they work a lot with cities and municipalities. And then the Climate Hub, who works a lot with our agricultural communities across our region. And with that, I finished you about 5 minutes before I said I would on the schedule. So I'll take any questions, or if you have any questions, feel free to put them in the chat.